Here's the next question, number 45. A full bridge converter supplying an RLE load is shown in the figure. The firing angle of the bridge converter is 120 degrees. The supply voltage Vm of t is equal to 200 pi sine of 100 pi t volts. R is 20 ohms, E is 800 volts, and the inductor L is large enough to make the output current a smooth DC current. Switches are lossless. The real power fed back to the source in kilowatts is dash. Okay, this is not a multiple choice question, so let's work it out. We have been given a couple of things. Let's write that down. We have the supply voltage Vm of t, which is 200 pi sine of 100 pi t volts. This. We have alpha, which is the firing angle, given to us as 120 degrees. We have been given R, which is 20 ohms, and E, which is 800 volts. Now the value of L is said to be quite large. It's very large and the value is not given. And the switches are lossless. We have been asked the real power fed back. So the real power is the output power P0, which in simple terms can be written as V0 into I0. Now we need to find out what are the values of V0 and and I0. So there is a general expression for V0 when we are considering circuits such as this. V0 is equal to 2Vm by pi cos alpha, where alpha is the firing angle. Alpha is the firing angle already given to us. Vm is the peak value of the equation given to us, which is 200 pi. So these are some basic formulas. The real power would be V into I, and V0 is written as 2Vm by pi cos phi. So if we substitute what Vm is, 200 pi here, let's see what we get. Okay. So we have V0 is equal to 2Vm by pi cos alpha, which is 2 into Vm. According to the given equation, we take the peak value, which is 200 pi, divided by pi into cos of 120. So here we get the value as, that's minus 1 by 2, right? So it's 400 into minus 1 by 2. So we have V0 is equal to minus 200 volts. So since we have V0 equals minus 200, let's take the magnitude alone. So the magnitude mod V0 is 200 volts. So we have V0, we still need to figure out the value of I0. So here we use the power balance equation. Power balance equation. Okay, so let's look at the circuit. Now, look at the output over here. Now, this is a place where we will have to concentrate. So, the power balance equation would be E times the output current I0 and the power dissipated by this resistor here, plus the power as a whole, the real power V0 I0. Okay, so I'll write that down here. E into I0 is equal to I0 square R, that's the power across the resistor, plus V0 I0, the real power. So we have the value of E as 800. We don't know what I naught is. We have the value of R as 20 plus V naught we just found 200. Now we solve for I naught. So that's 600 I naught is equal to 20 I naught square, and that cancels out. So we have I naught is equal to 600 by 20, and that's 30 amps. Now that we have the value of I naught, we have the value of V naught, all that's left is find out the real power feedback to source. So because we are finding out the real power, P naught is equal to a simple V naught I naught. And that's 200 into 30. 6,000, which comes to 6 kilowatt. That's about it. So now, let's see in what terms. It is in terms of kilowatt. So the answer is 6. Well, I hope this generalization has helped.